Welcome to the solutions to the starter as part of our gas pressure and gas laws video. This section was all about the particle model for gases, and we had two parts to cover. The first was to draw the particle model for a gas, which I have drawn here. And this is not exactly what you had to copy, but however you've drawn it, whatever you've done, make sure that there are two things that are absolutely clear. The first of these two, you must have gaps between your particles. That is non-negotiable because gases are the only state of matter where there are gaps between the particles. Liquids and solids do not have gaps at all. Liquids are very messy in their structure, but you cannot what we call compress them. You put some water in a syringe and close it and try and squash it, you won't get anywhere because water cannot be compressed, there are no gaps. The other thing that you should have made clear is that there is no overarching structure to your gas. Whatever you've drawn, it should not be nice and neat and ordered. Every box of gas that you draw and that everyone else watching this video has drawn will probably look different, yet could all be one gas because there is no structure, no repeating pattern, no anything when it comes to gases. So as long as you have gaps and as long as you don't have a structure, you are correct. You might be wondering what these lines are. Some schools draw them, I like to. They are speed lines, if you will. And they note that the particles have got different speeds and it also shows what directions they're traveling in. And that comes on to the second part, the sentence I asked you to complete. So, 2 words to describe the motion of gas particles. Well, the two I can use, and that I would suggest you use. Gas particles move quickly. As a rule, gas particles are pretty fast, and that should be something that you know. The other, and probably the more important, is that they move randomly. The motion of gas particles is random. They move in random directions with random speeds. So this one is moving to the right with a speed of 2. This one is moving to the left with a speed of 4. This one is moving down right with a speed of 2. This one is moving upwards with a speed of 3. I could go on. And we call that, this is not a GCSE term, but it's one that's quite nice to know. We call this, sort of this way that gases move, is called Brownian motion, which is actually something that Einstein would go on to use very, very heavily in their models, Brownian motion. So it is a very, very useful concept. Basically what that means is random directions and random speeds. Now you might not get marks on an exam for writing Brownian motion, hence I put it in another colour. But that is actually a really quick summary, or if you need to Google how gases move, that's the quickest way to do it. Now, the second part is to do with gas particles' interactions with each other and their container. And what we say there is that we have quite often collisions. So colliding makes the sentence fit grammatically. So what that means is that the gas particles are very often banging into each other. So as you can see here, if I look at some trajectories, this particle is going to bang into this particle. This one's going to probably bang into this one. This one's banging into the wall. This one's banging into the wall. It's probably going to pinball off and maybe hit this one. This one is going back and forth and therefore will probably hit this one at some point. There's a lot of collisions and banging into going on. Collision is the physics term. So that's what I wanted you to get down. So draw in a particle model if you haven't done so already. Something like mine will do as long as you have gaps and no structure. And for your sentence, gas particles move quickly and randomly, often colliding with each other and their container. This type of motion is known as Brownian motion if you want a little extra to add to your notes. So once you've completed that, the link to the main video so you can get back to things with pressure can be found in the description.